Your skin still carries machinery for a fur coat you no longer have. The muscles, nerves, and reflex still work, even though the thick insulating layer has mostly disappeared. Your body kept the wiring after losing the coat. Let's break down why humans lost visible fur, why Goosebumps survived, and what this leftover reveals about evolution. First, you are not truly hairless. Look closely at your arm under bright light, and you can see that most of your skin still contains hair follicles. The difference is that much of human body hair is short, fine, and lightly pigmented, so it does not form the dense outer coat you see on most mammals. Think of your skin like an old house that once had heavy insulation inside every wall. The insulation was stripped down, but the frames, cables, motors, and control switches were never completely removed. That distinction matters. Humans did not simply delete hair from the body. Evolution changed its type, length, density, and distribution. You kept thick hair on the scalp and more visible hair in certain regions. Across most of the body, however, the coat became thin enough for the skin underneath to interact directly with the air. Why would that help? Fur is excellent at one job and inconvenient for another because it traps a layer of air close to the skin, slowing heat loss in cold conditions. But when your body needs to release large amounts of heat, that same insulation can become a barrier. Sweat cools you only when it evaporates, and moisture trapped beneath a dense coat makes that evaporation less efficient. Second, the cooling trade. Humans evolved an unusually extensive system of eccrine sweat glands spread across the skin, releasing watery sweat directly onto the surface. As that water evaporates, it carries heat away, and a thinner hair layer makes it easier for air to reach the wet skin. Return to the old house analogy. Imagine replacing thick wall insulation with a powerful ventilation system that leaves the house less protected from cold, but much better at releasing excess heat. That is the trade. Reduced fur exposed more skin to the environment, while expanded sweating made that exposed skin useful. Scientists have not identified one single event or perfect reason for human hair reduction, because evolution rarely gives us a simple before and after story. But comparative evidence from primates supports the conclusion that reduced body hair and expanded eccrine sweating became linked features of the human lineage. That combination changed what your skin was for. In many mammals, the coat is the main interface with the environment. In humans, exposed skin became central to evaporative cooling. Third, the price of exposed skin. Better cooling did not arrive as a free upgrade, because reduced fur also meant less passive insulation. Exposed skin faced more ultraviolet radiation and more direct contact with the environment. One advantage created new vulnerabilities. That is an important rule. Your body is not a collection of perfect solutions. It is a stack of compromises. The same exposed skin that helps sweat evaporate also needs protection, while the same reduced coat that releases heat provides less help when the temperature drops. And that brings us to the mystery. If the fur coat became thin, why did the hair-raising system remain? Fourth, the old muscles. Attached to many hair follicles is a tiny smooth muscle called the arrector pili, and you cannot control it consciously. When it contracts, it pulls the hair upright and tugs on surrounding skin, creating the raised bumps you recognize as goosebumps. In the renovated house, these muscles are old motors hidden behind the walls, and although the thick shutters are mostly gone, the motors still respond when the wiring sends a signal. That signal travels through the sympathetic nervous system. You do not decide to raise each individual hair because the process happens automatically. In a densely furred mammal, this response can produce two useful effects. Upright hairs can hold a thicker layer of air near the skin, improving insulation. Raised fur can also make the animal appear larger during a threat display. Both effects depend on having enough visible hair. On your body, the same contraction still happens, but the outcome is much weaker. Fine human body hair cannot create the same insulating coat or dramatically enlarge your silhouette. The motor still runs, but the equipment it once controlled has been reduced. Fifth, cold flips the switch. When your skin is exposed to cold, sympathetic pathways can activate the arrector pili muscles. The hairs rise and the skin dimples. In a furred animal, this response can help conserve warmth. In humans, the effect is greatly reduced because the coat is sparse. Goosebumps are therefore not an effective replacement for fur. They are the visible echo of an older mammalian response. That is why the reflex feels so strange. Your body performs a movement built for a structure that has been dramatically reduced. It is like hearing an old heating system click on after most of the radiators have been removed. But cold is only half the story. Sixth, emotion uses the same wiring. Fear can raise the hairs on your arms, but so can awe, music, touch, and other intense experiences. A systematic review of 24 studies found that emotional piloerection is associated with signs of sympathetic activation, although major questions remain unanswered. The critical point is that goosebumps are not a simple emotion detector. They do not prove that you are afraid, and they do not mean one identical thing every time. Research using different stimuli has found that the wider autonomic response can vary with the trigger. Your nervous system reuses circuits. A pathway involved in a cold response can also be recruited during an intense emotional state. That does not require a new organ. It requires a new context for old wiring. Think again about the renovated house. A switch once connected mainly to heating may later become linked with an alarm or another control panel. The wire is old, but the triggers have multiplied. This is why a piece of music can give you goosebumps even when the room is warm. The skin response is one visible part of a larger emotional and autonomic event. It is not the entire explanation. Seventh, evolution does not clean the blueprint. People often imagine evolution as an engineer removing every obsolete part, but that is not how it works. Evolution modifies existing biological structures. If a reduced trait does not create enough disadvantage, every piece of it does not have to disappear. Removing the goosebump system would not mean deleting one isolated switch. It would involve muscles, nerves, follicles, connective tissues, and developmental pathways integrated into the skin. Biological systems share parts. A structure can lose one major effect while remaining connected to other processes. This is why an evolutionary remnant does not automatically mean a completely useless structure. It may be reduced, altered, or no longer serving the same dominant role it served in an ancestor. The arrector pili system may also do more than produce a visible bump. Eighth, the system may have another job. Animal research has shown that arrector pili muscles and sympathetic nerves interact with the environment surrounding hair follicle stem cells. In mice, cold stimulation activated both piloerection and stem cell activity associated with the hair follicle. That finding is fascinating, but the boundary matters. It does not prove that goosebumps promote hair growth in humans. It also does not prove that the reflex survived because of one hidden benefit. It tells us that the machinery is more biologically connected than it first appears. The old motor may still be attached to systems we are only beginning to understand. This is the deeper lesson inside your skin. Humans did not evolve by replacing an animal body with a completely new human one. You still use the same basic mammalian toolkit: hair follicles, sweat glands, smooth muscles, autonomic nerves, and temperature-sensitive pathways. Human evolution changed their proportions and priorities. The heavy coat became a thin covering. Exposed skin became a cooling surface. The sweat system expanded while the old hair-raising reflex remained. That is why goosebumps are such a powerful evolutionary clue. They are not proof of one simple story. They are a visible compromise between an older body plan and a newer way of controlling heat. The next time your skin rises during a cold wind or a piece of music, notice what is happening. Tiny muscles are pulling on tiny follicles, while sympathetic nerves activate without your permission. A system built for fur is still responding inside a body that relies far more on sweat. Your skin is modern. The wiring is ancient. Every goosebump is the old house reminding you what used to be there.